All right, let's switch gears a little bit. I'll close all the existing tabs, and because I've made a couple changes here and there, some of the tabs are going to say, "Oh, are you sure that you want to not save your progress or whatever?" But I still have that link that was shared earlier in my clipboard, so I just pasted that, and we're back to right where we started. Now you can graph functions as we've done here, or let me start clearing away some things and say, how about we graph, x plus h quantity squared plus y plus k quantity squared equals r squared. Or I guess it'll be more natural to have a minus h and a minus k there. And then do we want to add a slider for h or for k or for r? We'll just add sliders for all three. Maybe it'll make more sense to naturally set the value of the h slider to 0, set the value of the k slider to 0, and sure, we'll start the radius at 1. So I could imagine already right here having a project that's ready to go and click this to create a new link, but let's not do that yet. How about let's also graph a point. Maybe we'll graph the origin, right? Just like that. Okay, and then oh, we've added the sliders. They're really already implemented, right? Because the role of these three parameters are in their appropriate place here. So we're just trying to really demonstrate that in addition to graphing functions, which we were doing earlier as a y equals some expression in x, you can graph an equation in two variables x and y. So if you wanted to start, you could graph x plus x minus 0 quantity squared plus y minus 0 quantity squared equals 3 squared, and then place that up here to start, and maybe I guess we should start the radius at 3 as well. You can do something like that. So you could have I could imagine, for instance, someone wanting to turn off the circle that's in red, the one that's going to be controlled by these sliders, and just start with x minus 0 squared, or even without the minus 0. Just start with, oh dear. Start with, get rid of that parenthesis, it's confused. Okay, yeah, I could imagine wanting to start with just something like this, x squared plus y squared equals 9. To begin with, the circle that was in red is currently non-showing. You can click to show it, but maybe it starts like this as what it will permanently look like if you clicked on this link right here. I mean, I'm probably causing the Desmos folks some stress with like, another link was created and this link is tied to this data right here that looks exactly like this. So we could, so we've done that, right? We've created this link, and I copy that link, and I can share that link with you, or I mean, it's kind of not fully visible here, but I can open it in a new tab, and so check out that here, this address was the one that we first shared. Here's the new one, and I don't even have to load it up, but if you loaded this, you'll get what's currently showing right here, right? You'll get this circle of radius 3 and so on and so forth. Now, I guess we have a problem because if we oh wait, first I should turn on this in red. As we start shifting the circle, the center didn't move, so maybe it makes more sense to do something like this, or I guess we don't even need the 0 plus business here, right? So now the slider here controls both the equation in x and y and this point, but I guess we can just remove that. That looks a little silly now. Okay, great. So again, if I go to this tab where we had created this link based on a different version than what's here, the sliders for h and k in particular were 0, that's what we'll see when we load this up. Right? So we have this information if we had saved this link, written it down, or copy pasted this into a text editor or whatever. Back over here, if we were to reload this, it'll say, hey, all these changes you made since loading this, you don't have a record of that. I mean, we do because of the other link, right? But here it's back to what we had. Now, let's say here with this this is again, I think, in a really, oh, sorry, this doesn't have a feature that we'd want, perhaps, like the now I think this is featured in set up in a way that I would want to now take this new link. Here's a third link created. I could imagine storing this link and having that ready for class. I could then turn this on. I could make the radius really huge. Maybe I need to use my mouse scroll wheel to zoom out. I can also change the view of, the how much of the x-axis and y-axis we're seeing here. Maybe I want to zoom really far out, something like that. Maybe this got a little too distorted, so I'll just create the zoom in the form of square shape, so the x and y axes are scaled properly relative to each other. One other thing that I think may be worth pointing out here is that we could just kind of preview some of the features that students might use if you gave them a project of drawing. It will really, students tend to really love these projects, and it'll get them to really dig into the algebra geometry correspondence that's going on here. So for instance, I could imagine wanting to create, instead of, let's turn off this basic circle, let's even turn off this point that was the center. I could imagine wanting to take the circle and say, have it filled in, right? So if students are really being artistic, maybe you want an inequality, and then they may not want that circle to be, that filled in disk to be red. Maybe they want it to be blue. They can do that. I can imagine somebody saying, well, I'm trying to design the shape of a certain kind of glass that stores stuff, so I don't want any of the stuff that's up here. And so there is, for better or worse, a way to create a restriction to say, graph all of the points satisfying this inequality, but in addition, this additional restriction must be satisfied. So here, y less than or equal to 5. It sort of struggles. I wish this were filled in solid along this edge. But you could, if a student's really bothered by that, you could say, well, why don't you just create a horizontal line there, and then do a restriction on that where the x value has to be between, I guess it's here. You can make them compute it, I guess, using the Pythagorean theorem, but negative 8.66. So negative, how about like absolute value of x is less than or equal to negative 8.66. What am I doing wrong here? Is that too complicated, perhaps? Let's just design that a little easier. How about this less than or equal to x? Yeah, I guess it was just too complicated. I was trying to, oh, and then of course maybe that shouldn't be in red, right? So we go here, make that blue. Okay, and so that we have some nice shape that looks like this. It should, oh, right. And so one could challenge a student to figure out, wait, that little piece isn't moving alongside this. What would I need to do here? I guess probably do a plus h, or is it a minus h? Well, just, oh, that worked out. So what have students done like this? Well, go to desmos.com/art, and there's this art contest. Here I am in the, by default, the ages 13 and 14 category. So let's just take a look at the first place winner in that age group. And I guess this student, went here and turned off the graph grid. You could, just because the giraffes are here in place. But you could, this student also organized things into various folders. So I could turn off the visibility of one little line. I thought that was a line segment, but you can see it's a parabola function of y here, right? A sort of a sideways piece of a sideways parabola. You see that kind of restriction going on. So right giraffe outline. Oh, I see. And then you could see that the left giraffe's spots. Oh, I didn't know about this polygon thing. Okay, that's neat. But maybe I'll zoom out a little bit and see. It can turn off the visibility of one thing. I don't know what thing is being turned off or on. Maybe the entire folder, the entire group of things can be turned off and on. Okay, so you can just see that, even a 13, 14-year-old is designing some really imaginative things here, just by making use of graphing, lines and parabolas, probably for the most part. and doing inequalities. And I guess I didn't know about this Polygon tool, but this is a really, really, awesome thing, thing that you can see. Oh, students already got objects. You can have sliders that, in fact, automatically animate. I mean, I can see that being fun in this artistic sense. There's these bubbles that are blinking on and off. I don't actually even know how to do that. But you could click on a slider like over here to animate it. Oh, and you see that I've got a design flaw here by doing that. So I'll just turn on this one. I'll zoom out a little bit right there. But you can take a slider and have it animate on by default. So if we clicked right now and share, this will animate, or we could by default have it not animate, and then in that exploration phase have it animate. You can see the animation on this currently is back and forth, bouncing back and forth. You can set it up so that you just continuously only go in one direction, things like that.